Welcome to the Introduction to Generative AI. If you're unfamiliar with the concept, you're in the perfect place. In this video, I'll cover 4 main topics: defining generative AI, explaining how it works, describing the different types of generative AI models, and exploring generative AI applications. Before we dive in, don't forget to hit that subscribe button and ring the bell icon. This way, you won't miss any of our exciting videos. Let's begin by defining generative AI. Although it has become a buzzword in recent years, what exactly does it mean? Generative AI refers to a type of artificial intelligence that can create various forms of content, such as text, images, audio, and even synthetic data. Unlike traditional AI, which might be focused on classifying data or making predictions, generative AI is about creation, generating new, previously non-existent content. To better understand generative AI, let's first discuss the broader concept of artificial intelligence, AI. AI is a branch of computer science focused on building systems capable of performing tasks that typically require human intelligence. These tasks include reasoning, learning, problem-solving, perception, and language understanding. AI can be thought of as a discipline, much like physics is a discipline within the broader field of science. AI is essentially about creating intelligent agents, systems that can reason, learn, and act autonomously. These systems are designed to mimic human cognitive functions, making decisions based on data, learning from experiences, and adapting to new information. There are various subfields within AI, including machine learning, ML, natural language processing, NLP, robotics, and more. One common way to conceptualize AI is to compare it to human learning and intelligence. Humans learn from experiences, adapt to new situations, and apply their knowledge to solve problems. Similarly, AI systems are designed to learn from data, recognize patterns, and make decisions. The goal of AI is to create systems that can perform tasks with a level of competence similar to or surpassing that of humans. Now, let's delve deeper into machine learning, ML, a crucial subset of AI. ML is the study of algorithms and statistical models that computer systems use to perform tasks without explicit instructions. Instead, these systems learn from data and improve their performance over time. There are 3 main types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning involves training a model on a labeled dataset where the desired output is known. The model learns to map inputs to outputs based on this training data. Common applications of supervised learning include image recognition, spam detection, and predictive analytics. In contrast, unsupervised learning deals with unlabeled data. The model tries to identify patterns and relationships within the data without prior knowledge of the outputs. Clustering and association are common techniques used in unsupervised learning. For example, unsupervised learning can be used to group customers based on purchasing behavior or to detect anomalies in network traffic. Reinforcement learning is a bit different. It involves training an agent to make decisions by rewarding it for desirable actions and penalizing it for undesirable ones. Over time, the agent learns to maximize its cumulative reward. Reinforcement learning has been successfully applied to various domains, including robotics, gaming, and autonomous driving. Supervised versus unsupervised learning. To illustrate the difference between supervised and unsupervised learning, consider a practical example involving a restaurant owner. Suppose the owner wants to predict tips based on past bill amounts and order types, pickup or delivery. Using supervised learning, the model is trained on historical data containing both bill amounts and tip amounts. By learning from this data, the model can predict future tips based on new bill amounts and order types. In contrast, an unsupervised learning approach might involve analyzing employee data to identify patterns. For instance, the owner could use unsupervised learning to group employees based on their tenure and income. The model would identify natural clusters within the data, which could help the owner understand employee retention and performance. Understanding deep learning. Deep learning, a subset of machine learning, has revolutionized the field of AI. Deep learning models use artificial neural networks, which are inspired by the human brain. These networks consist of interconnected nodes or neurons that process data in layers. The more layers a network has, the deeper it is, hence the term deep learning. Neural networks are particularly powerful because they can learn to recognize complex patterns in large data sets. Each layer of neurons in a deep learning model extracts increasingly abstract features from the input data. For example, in image recognition, the first layer might detect edges, the second layer might detect shapes, and subsequent layers might recognize objects and faces. Deep learning models are used in a wide range of applications, including speech recognition, image classification, natural language processing, and game playing. One of the most significant advancements in deep learning is the development of generative models, which we'll explore in more detail next. Generative AI is a specialized branch of deep learning focused on creating new content. It leverages artificial neural networks to process both labeled and unlabeled data through supervised, unsupervised, and semi-supervised methods. Generative AI models can produce realistic images, coherent text, convincing audio, and even synthetic data that closely resembles real-world data. Large language models, such as OpenAI's GPT-3 and Google's Pathways language model, PaLM, are examples of generative AI. These models are trained on massive amounts of text data and can generate human-like text based on given prompts. For instance, you can ask a generative language model to write an essay, create a poem, or answer questions in natural language. Generative models versus discriminative models. It's essential to differentiate between generative models and discriminative models. Discriminative models are designed to classify data points or predict labels based on input features. They learn the conditional probability distribution, P(x), where y is the label and x is the input. For example, a discriminative model might classify an image as either a cat or a dog. Generative models, on the other hand, learn the joint probability distribution, Pxy, and can generate new data instances based on this distribution. Instead of just classifying an image as a cat, a generative model can create a new realistic image of a cat. This ability to generate new data is what makes generative models so powerful and versatile. To summarize, generative models can create new data instances, while discriminative models differentiate between different kinds of data instances. For example, a traditional machine learning model might predict sales numbers, while a generative AI model could generate a natural language report on sales trends. Applications of generative AI. Generative AI has a wide range of applications across various industries. Let's explore some of the most prominent ones. Content creation. Generative AI can assist in creating content for blogs, articles, and social media posts. By providing a prompt, the model can generate coherent and contextually relevant text. This capability is particularly useful for marketers, writers, and content creators looking to streamline their workflows. Image generation. Generative AI models can create realistic images based on textual descriptions. This technology is used in graphic design, advertising, and entertainment to generate visual content quickly and efficiently. For example, artists can use AI to create concept art, or designers can generate product images. Audio synthesis. Generative AI can produce high-quality audio, including music, voiceovers, and sound effects. Musicians and producers can leverage AI to generate new compositions or enhance existing tracks. Additionally, AI-generated voiceovers can be used in podcasts, audiobooks, and virtual assistants. Synthetic data. In fields like healthcare and finance, generative AI can create synthetic data sets that preserve the statistical properties of real-world data while protecting privacy. Synthetic data can be used for training machine learning models, conducting simulations, and testing software without compromising sensitive information. Chatbots and virtual assistants. Generative AI powers advanced chatbots and virtual assistants capable of understanding and responding to natural language queries. These systems can provide customer support, answer questions, and perform tasks, enhancing user experience and reducing the workload on human agents. Game development. In the gaming industry, generative AI can create game assets, design levels, and even generate narratives. This technology allows developers to build more immersive and dynamic game worlds, offering players unique experiences each time they play. Personalized recommendations. Generative AI can analyze user behavior and preferences to generate personalized recommendations for products, services, and content. This application is widely used in e-commerce, streaming platforms, and online advertising to enhance user engagement and satisfaction. Medical research. In healthcare, generative AI can assist in drug discovery, medical imaging, and personalized medicine. For example, AI models can generate molecular structures with potential therapeutic properties, aiding researchers in identifying new drug candidates. As we conclude our introduction to generative AI, we've explored the foundational concepts, capabilities, and potential applications of this transformative technology. Generative AI, with its ability to create text, images, audio, and more, holds immense promise for enhancing various workflows and driving innovation across industries. In the next video, we'll dive into the challenges and ethical considerations surrounding generative AI. We'll address concerns such as the misuse of AI-generated content, the environmental impact of training large models, and the biases that can emerge from training data. Moreover, we'll explore Google Cloud's tools, including Vertex AI, Vertex AI Studio, and the PaLM API, which provide robust infrastructure and pre-trained models to support the development and deployment of generative AI applications. Thank you for joining us in this journey through the fascinating world of generative AI. Be sure to subscribe to our channel for more in-depth explorations and practical applications. If you found this video informative, please give it a thumbs up and share your thoughts in the comments below. By understanding and leveraging generative AI, you can unlock new possibilities and drive innovation in your field.